Define intramolecular forces. First, distinguish between intermolecular forces between molecules and intramolecular forces within a molecule. In this context, intramolecular forces refer to the chemical bonds, covalent bonds, holding the atoms together. Identify the core concept. The strength of a covalent bond is primarily determined by its bond order, which is the number of shared electron pairs between two atoms. Generally, triple bonds are stronger than double bonds, which are stronger than single bonds. Analyze the bond order for each option. In 2, C nitrogen has 5 valence electrons. To achieve an octet, 2 nitrogen atoms share 3 pairs of electrons, forming a triple bond. O2, D oxygen has 6 valence electrons and forms a double bond to complete its octet. F2, E fluorine has 7 valence electrons and forms a single bond. BCl2, A beryllium forms single bonds with each chlorine atom. So too, B as established in the previous question, so too is a resonance hybrid where the bonds are intermediate between single and double bonds, a bond order of 1.5. Compare bond strengths. Compare the bond types identified. A triple bond requires significantly more energy to break than double, single, or intermediate resonance bonds. Conclusion: because N2 contains a triple bond, it has the highest bond order and thus the strongest intramolecular forces among the choices provided. The correct answer is option C, N2.